Determine the behavior of the function near the vertical asymptote. The vertical asymptote is what number?
2.
2. So I'm going to highlight that right here. If it'll stay for me. Hold on. What is happening?
Maybe you should do a bit to the left.
Let's see. Hold on. Hold on. There we go. Okay. So it is at 2. Now, remember that this negative sign means from the left side of that asymptote. So I put my finger here or my pen here and I go to the left. If you notice, where is it going? Where is the arrow going? Down to where? Negative infinity. Now, I will explain that one more time. So watch my color pen. Here I am to the left. It's okay. It's all right. Just keep it there for now until I'm done explaining. It's okay. We'll get it in a second. Because I want you to understand. All you're doing is looking to the left of the line and saying, where is the arrow going? So here I am in red. Here I am in red. I'm going down, 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 down. I'm going down to negative infinity. Okay, that's when you're talking about asymptotic behavior is actually what it's called. Thank you for picking that up. So again, where is the arrow going? Where's the end behavior as it's going towards that from the left side? Now if we go on the right side, so that was C. Now let's go to the right side. Again, here I am on the right side of my asymptote. Follow the graph in pink. Where is it going? Going to positive infinity. You see how it's starting to go up towards my asymptote, but it's going up to positive infinity. And that was B. Okay, that one is very similar to the one you're going to have on the exam on Thursday and Friday. Okay? All right. Now, what we're going to do today, we will go over the homework. We're going to go over it at the end of the class period. Okay, we will go over it though. But I want to make sure we get through what we need to get through before we do so. So all I need to do is start cutting these out. You have one big square. This is going to be one of the biggest resources you have on this test. And then you also have that little bitty chart. Remember I promised you put a chart in there about horizontal asymptote that Jake's picking up right now. If you don't have that little guy, please make sure you have it. So please start cutting those out. Right now you can kind of talk and hang out, that's fine. But lower voices. You don't need to be screaming in here. You're fine.
Just say what I found my homework.
Oh, you did?
Yeah.
That's nice.
Did I get full points?
We'll see how today goes.
How does this little
We need this too.
Yeah, you do. You just want to cut around the big square. I outlined the square for you.
Okay.
That's it. And then you want to glue both of them in. Does it matter the order? All right. Here we go. I'm going to start here with the chart because it's the easier part of this. So this chart, please flip to that on your graph. It looks very similar for a reason because you already took notes on this in the past. I screenshotted it so you can have it in your interactive notebook. The horizontal asymptote, think of the sun. The sun is your horizon. When the sun rises, you're looking at the horizon. Okay? What value is that? Is that X or Y? Y, your horizon. Okay, so that's your Y values. That's your horizontal asymptote is your Y. It's when it approaches a value but never touches it. Okay? So there were 3 conditions that we've already learned, but I'm going to recap it for you here. When the degree of the denominator, I'm just going to highlight it with one of the colors I have. It doesn't really matter which one. When the degree of a denominator is larger or bigger, either one. Do you like larger or bigger better? Larger. Okay, let's put larger. Then the degree of the numerator, then automatically you have an asymptote at y equals 0. And here's what I'm going to do. This is probably the most important part here, is this piece, because that's what I'm going to be asking you for. Tell me what the horizontal asymptote is. You're not telling me the degree. You're telling me one of these. So when I ask you for something on the exam, your answer should be looking like something like this that I highlighted here. Okay. If the degrees are the same, that's when we did our ratio of those numbers all the way out in front. So I'm just going to do this example one with you again so that you can have something to look off of. We've already did it in the past interactive notebook, but let's take the time to do it in this part. Let's start with the first one, actually. What's the degree of the top? 1. What's the degree of the bottom? 2. Which one's higher? The bottom one. Okay, that's why y is equal to 0. What about this one? What's the degree of the numerator here? 2. What's the degree of the denominator? 2. So they're the same. And that's why I have to take the ratio of the leading coefficients. So here we go. What is 2 divided by what number is out in front here? A 1. So I have y equals 2 divided by 1, which is 2. Very good. So that's the only one you actually have to do some kind of math for. The other ones, it's just looking at the chart. The next one, here we go. What's the degree of the numerator?
3.
What's the degree of the denominator? Which one's higher?
3.
So because the numerator is higher, I have no horizontal asymptote. So remember, when I ask you, what is the horizontal asymptote? Your eyes should be going to here. That should be what your answer looks like. But you're looking at the degrees. So I told you that would be in your interactive notebook. Maybe at the top of the page. Well, it kind of already has a title, so never mind. All right, let's flip to the graph, and then we're done. Okay, so we really don't have much left. That's why I wanted to take the time in the beginning to go over your grades and what's going to be coming in the next couple weeks. All right, graph. This one is identical to the one on your exam. I think I just changed the numbers. The 3 numbers that are there, I changed them. That's it. So I might have changed 4 to a 2 or a 1. That's it. So it's exactly the same. So it's something so that you can look off of in case you struggle. So here's your 2 different color highlighters. Identify any discontinuities. That just means what makes the bottom equal to 0. So here we go. I'm going to come right here just so you know this is where it's coming from. What makes x minus 3 equal to 0? What makes x minus 3? Yeah, I have to add 3 to both sides. So if you need to write down the equation, do so. So x cannot be 3. I only have 1 because there's only one x in the bottom. Questions on that? Now, your goal is to find out, is it a whole or an asymptote? So we described it, it's 3, but which one is it, a whole or an asymptote? Good, because it does not cancel. And if you look at the previous page of your interactive notebook, we highlighted that. X minus 3 does not cancel with anything on top. It has to be exactly the same.
So it does cancel to 4, right?
Yes, very good. So my line is x equals 3. That's the line. You don't want the not equal to because that would not be a line. Now, here's what I'm going to do. Take one of your highlighters and highlight vertical asymptote. I'm going to draw out my x equals 3. So I kind of have this graph here for you so we can do this. Is vertical going to be like left and right, or is it going to be up or down? Up and down. So I'm going to go ahead and put my highlighter here. That now formed a wall. My function, when you draw it, cannot touch it. It approaches it, but doesn't touch it. Now let's do the horizontal. And here's what I'm going to do. Remember we did this a couple of days ago in our interactive notebook. What is the degree of the top of my function? 1. What's the degree of the bottom? 1. So is it higher than the top, bottom, or the same? The same. So that means I must go back and look at the numbers out in front. 4. Very good. So y equals 4. Okay? And that came from, let's do a different color here. And I'm going to highlight this piece because that's where it came from. The horizontal asymptote came from the ratio all the way out in front, 4 divided by 1. Now let's draw it in. So I have to go up to 4 and draw this in. Now what's really nice about this is now you have a guide on how to draw your graph. You can't touch these lines because it doesn't exist there. But now from this point forward, I think it's pretty easy. The hardest part is finding this information. get out your graphing calculator because you need to be able to sketch this on the test. So let's practice together. I'm going to get mine out, and I'm going to go to y equals, like we always do. Y equals. Clear it out if there's anything in there. And let's see what we got. You have to be very careful when you plug this into the graphing calculator. You must put, so right now in your interactive notebook, let's do this so that we don't forget. Maybe like get a red pen or a different color pen or something to note that you must use parentheses around the top and the bottom. Well, I guess you really don't need it on the bottom. I can erase that part. Just the top for this part. Most of the time you do need it on the top and bottom, but for this case we don't because there's not more than one group. If there was another group here, you would have to. So let's go ahead and plug that in. Or you can distribute first, whichever one. So I have parentheses 4, parentheses again, x minus 1, x minus 1, close it up. You have to do that only because of that 4 out in front. If that 4 wasn't there, yeah.
One parenthesis, then double again. On the right.
Well, we'll see if it looks the same. And then I have divided by what? X minus 3. X minus 3. Press graph. And take a look at it and see what it looks like. Did I do something wrong? Let's look. Oh, I forgot my dividing sign. Thank you. Right here. I apologize. Divided by parentheses x minus 3. Sorry about that. Go to your y equals and make sure that you have the dividing sign. I definitely forgot that. Now, when you looked at the graph, it looked weird. Let's take a look at this one. Now look.
I don't have that.
Oh. Oh.
You're missing that. So if you here, just something to check to see if you did it right. Take a look though, because you can see if your graph is valid. You have a horizontal asymptote at 4. Let's look. 1, 2, 3, 4. Does it look like they're slowly approaching this line right here?
Yeah.
Okay. It also says I have a vertical asymptote at 2. Right? Was it 2 or 3? I don't remember. It was 3. So 1, 2, 3. Does it look like if I drew a line here, it would be approaching it but not touching it?
See, I didn't get that. Even when I did.
Did you look at your divide sign? I'll come to you in a second. All right, last part. So just sketch it. So it looks like something like this. I'm not asking for a perfect graph. I'm just asking that it looks something along the lines of the graph on your calculator. And it looked like this. And if you saw how I drew that, I went off of the lines I already drew in. That's why we put those in highlighter. I kind of just like followed those asymptotes. I followed the asymptotes. What your calculator is doing for you is seeing which way it's going, because it could go a different way. Yeah.
There's something I'm curious about. How would these change if
I'm trying to listen. What?
What if the horizontal asymptote was near the bottom, like in the negative area?
It's okay.
How would that change the lines themselves?
I mean, it would just look like this. Like if it was in the negatives, it would just be shifted down, the whole
So
thing.
it doesn't really change what the lines look like then.
Well, sometimes it depends. If there's a negative out in front, it could look like this.
So really,
It-
it's going to be the same end behavior anyways.
Yes, it's going to be the same end behavior in general because of the horizontal asymptote. But that's only because we have the same degree. If they didn't have the same degree, it might look different. But that's why we have a calculator to help us out. All right. I can explain one-on-one when we're done here. We're almost there. The end behavior. This is easy if you just remember the trick I told you. Does anyone remember the trick I told you from yesterday and the day before and the previous day about end behavior?
The same as your vertical.
not your vertical, your horizontal. So highlight with the same color highlighter as your horizontal asymptote. Mine was yellow. Because that's your answer. Here's why. So my answer, my horizontal asymptote was at 4. So I'm just going to put those in. And maybe make a note to yourself that that was your horizontal asymptote. Now I'm going to explain to you why. As x is going towards negative infinity, I remember I like to write these out just to make sure that I'm understanding my infinity signs. As x is going to negative, here I am, I'm walking towards negative. My function, I'm going to kind of sketch it out for you in blue, is approaching 4. Do you see how it's slowly approaching 4? Okay, it won't touch it, but it's slowly getting there. And same thing on the other side, as x walks all the way to infinity, just stay there. This blue line is going towards 4. Now the other part. This was the one that was on the bell ringer. So something to mark. Your vertical asymptote, I'm going to highlight with the same highlighter that I use so that you know that that's what I'm looking at. As I'm approaching 3, I'm put like a little star here. From the left, so here I am, I'm going to the left. In green, where is my function going?
Positive?
From the left?
Oh, 0. Oh, down, negative.
Down to negative, very good. Now, same thing, but now we're looking at the right side of it. So take a look. So again, like I'm going to cover all this up. That's the left side. Cover this up. That's the right side. So let's look at the right side. Do you see how in green it's starting to slowly go towards, or actually rapidly go towards, positive infinity as it's going towards this blue vertical asymptote? So you see how it's getting closer and closer and closer, it's going up. So we're going to positive infinity. We're almost there. Last part. Your domain. What affects your domain, the vertical asymptote or the horizontal asymptote?
The vertical.
Very good, the vertical. So I'm going to highlight with the same color, vertical asymptote, the domain. They go hand in hand. It's crazy how the numbers you're using keep reoccurring. There's a reason for it. Now watch. What do I always start with for domain? Good. And where do I always end?
Positive 0.
I always end at positive. Now I kind of just like set this up. You don't have to do that right away. I was just setting myself up because I don't want to keep scrolling up and down. Now here we go. You don't do this actually because I don't want your graph to be all weird. But I want to show you with my highlighter what I'm talking about. So I'm just going to use a green highlighter. I'm always starting at negative infinity. Remember, domain is your x. Where does my domain stop?
3.
What's that number, Jake?
Oh, 2,
This number? What's the line?
3.
3. Do you see how I kept going and then I stopped? Okay, that's 3. So I'm going from negative infinity to 3. And then 3 to where? Positive, yeah. So wherever you stop is where you start. And just to visualize it again, I start back up at 3 here in green, and I keep going until I go to positive. That's how you're doing domain. I want you to visually see it. Okay, we are done for today.
HW.
I'll talk about it in a second.